Hello, classmates. We know that after the alternating current passes through the rectifier circuit, the output becomes pulsating direct current. To make the output direct current smoother, a filtering circuit must be added. Today, we will learn about the single-phase bridge rectifier with a capacitor filter circuit. The objectives of this section are: first, to be able to explain the working principle of the single-phase bridge rectifier capacitor filter circuit. Second, to be able to perform the assembly and testing of the single-phase bridge rectifier capacitor filter circuit. The output of the rectifier circuit is pulsating direct current, except in some special occasions, such as electrolysis and electroplating. Usually certain measures need to be taken to reduce the pulsating components it contains, while trying to retain as much of the direct current component as possible, to make the direct current output smoother. Such measures are known as filtering. Filtering generally consists of capacitors, inductors, and other reactive components. For example, by paralleling a capacitor C across the load, or by connecting an inductor L in series with the load, and combining capacitors and inductors to form complex filter circuits. The following figure shows several common types of filter circuits. These circuits are, respectively, capacitor filtering, inductor filtering, and pi-type filtering circuits. At the front end of the load in a single-phase bridge rectifier circuit, the capacitor is connected in parallel. Note that the polarity of the capacitor is positive on top and negative on the bottom. This forms a single-phase bridge rectifier capacitor filter circuit. At this point, the voltage on the capacitor UC, which is also the load voltage UL. The final waveform after filtering is shown as the solid line in the figure. Compared to the waveform after rectification, it has become much smoother. Let's take a closer look at the working principle of the circuit. This graph shows the waveform of the output voltage on the load, which is also the waveform of the voltage UC on the capacitor. During this interval, the voltage on the secondary side of the transformer U2 rises. U2 is greater than the voltage on the capacitor UC, so U2 charges the capacitor. The voltage on the capacitor is also the output voltage, which changes with U2. At this time, UO equals to UC is approximately equal to U2. When U2 reaches its peak, the voltage on the capacitor also reaches its peak. Square root of 2 U2. At this point, the waveform of the U2 begins to decline because the voltage on the capacitor is square root of 2 U2, so U2 is less than the voltage on the capacitor. The diode is reverse biased and cut off. The capacitor C discharges through RL. UC decreases exponentially with a time constant T equals RLC. The second question. Let's look at the characteristics and parameter calculations of the capacitor filter circuit. The average output voltage UO is related to the discharge time constant RLC. The larger the RLC, the slower the capacitor discharges. The greater the average output voltage, the smoother the output voltage waveform. This formula can be used to make an approximate estimation of the output voltage and current. UO equals to 1.2 U2. IO equals to UO per RL. The instantaneous current passing through the diode is very large. RLC. The larger the RLC, the higher the output voltage. The greater the average value of the load current, the shorter the conduction time of the rectifier. The greater the peak current passing through the rectifier, the highest reverse voltage a diode can withstand. Is also the maximum value of U2, square root of 2 U2. Under a certain load condition, the larger the capacitor C, the better the filtering effect. The value of the capacitor can be selected experimentally according to the following formula. C greater than or equal to 2T per RL, where T is the period of the power supply voltage. The rated voltage of the capacitor should be chosen to be greater than square root of 2 U2. Safe selection of the diode. Due to the high output direction current voltage, the rectifier diode has a long off time. The conduction angle is small, so the surge current of the diode is relatively large. It is important to avoid current surges that could damage the diode. When selecting the diode, the operating current of the diode should be much less than the maximum rectification current of the diode IF. The reverse voltage the diode can withstand should be less than the highest reverse working voltage of the diode. Let's now conduct an experiment with the single-phase bridge rectifier capacitor filter circuit. Connect the circuit according to the diagram. First, connect the 4 rectifier diodes properly. Connect the cathode of D1 to the cathode of D2. Connect the anode of D3 to the anode of D4. Connect the anode of D1 to the cathode of D4. Connect the anode of D2 to the cathode of D3. Set U2 to 9 volt. Connect the anode of D1 to the 9 volt on the secondary side of the transformer. Connect the anode of D2 to 0 volt. Use a 470 microfarad capacitor. Connect the cathode of D1 to the positive terminal of the capacitor. Connect the anode of D3 to the negative terminal of the capacitor. Select a 1 kilo ohm resistor as the load. Connect the positive terminal of the capacitor to one end of the 1 kilo ohm resistor. Connect the negative terminal of the capacitor to the other end of the 1 kilo ohm resistor. Connect both ends of the load to the oscilloscope. Turn on the oscilloscope. You can see this waveform, which is the output waveform after rectification and filtering. Compare the output waveform of the single-phase bridge rectifier circuit with the output waveform of the single-phase bridge rectifier filter circuit. It can be seen that after filtering, the waveform is significantly smoother. What are the advantages and disadvantages of the capacitor filter circuit? The advantages of the capacitor filter circuit are simple structure, increased output voltage, reduced pulsation component, significantly reduced diode conduction time. The disadvantages of the capacitor filter circuit are: the load current should not be too large. When the load current is large, it can cause a drop in output voltage, increase the ripple, affecting the filtering effect. Therefore, capacitor filtering is suitable for applications with little load variation and where the current is relatively small. When the load current is large, integrated voltage regulators can be used for voltage stabilization. Alright, that concludes the content for today's lesson. Goodbye, classmates.